If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in advanced level where you are solving previous year IIT JEE questions on vector algebra. So today again we will be solving from question number 15a to up to 18c. Okay, then let's try to solve these questions. Now if you come to 15a, a, b, c, d are the four distinct vectors satisfying these conditions. So that these and these are not equal. So you have to check which one is not. Now they are asking you not to show this one. What is the meaning of this one? You can simplify this one. This is not equal, they are asking. That means if you bring it this side, these two should, and if you take a taken out of this dot product, you can take common, so it is b minus c, and d it is c minus b. So these two should not be equal to 0. And here also you can take b minus c common, then it is a minus d, because if you take b minus c it will be minus, so it will be a minus d. So these two dots should not be 0. So that means they should not be, dot means when dots are 0, when they are perpendicular. So they should not be perpendicular. Okay, that's what they want to prove us from this. So what is given to you is this. So you need b minus c, a minus d. So let's subtract these two. What is, if I subtract these two, you can take a as outside because it is pre-multiplied with b and c. So you can take open this bracket. While you are taking common in cross, you have to be careful because cross is not commutable. You cannot change the order. Dot you can do, c dot b, b dot c, you can do it. But here a cross b, b cross a are not equal. So if you are subtracting it, a is pre to this one, pre to this one. So you can take common as a pre. You cannot take common from this one. For this taking common, you have to change this order. That is a cross b. Suppose it is c. So now you can take a common. That is b cross c. B plus c, a cross b plus c. Because here a is just pre and here a is post, so you cannot take common. But in dot you can take common because dot can be changed. So you have to be careful about this. So if you take a common, b minus c, c minus d. Now if you bring it again this side, so it will be c minus b. You can change it to b minus c. Okay. Now you have to change the order because b minus c, you can see this is a vector also, bc. So you cannot take common because b minus c is there at the post. After, here it is pre, so if to convert it I have changed it to position. Now you can take common, b minus c you can take after because it is after, so you can take common after, so it will be a minus d because it is after. So if you take common also, it will be after. So this cross this 0 means these two vectors are collinear, their angle is 0. So then in that case the dot will never be 0. If they are collinear, then dot is not 0. Dot is 0 and they are perpendicular, so obviously they are not perpendicular. So obviously this is not equal to 0. Again 15b relates something related to 3D. So let's go to 16. 16a. ABC are three non-zero, non-coplanar vectors. B1 is given this one, B2 is given this one, C1 is given this one. Long expressions are given. C2, C3, C4 is given this one. The set of orthogonal vectors. So for that you check option because you have to do nothing. Which of these are orthogonal means all three should be mutually perpendicular. So dot a dot b1, b dot c1, a dot c3 all should be equal to 0. So let's start with a dot b1 is equal to 0, b dot c1. Let's start with option A. So a dot b1. So you dot it, b1 is this one, you dot it with a. So it is a dot b, and here it will be a dot a means mod a square will get cancelled because it is scalar, so it is b dot a dot b, or b dot is same, so it is 0. So obviously this one is satisfying. Next check a c3 because b1 and c3, if you do b1 and c3 it will take some time. So it's better if you do a and c3. So a and c3 will be a, normal a, and then c3. So c3 is this one, you do this one, then a dot c, and here it is a square, and here it is a dot b1 will come. A dot b1 you have already calculated 0, so this side is 0. So you have to look like this. Obviously this is not equal to 0, you can see. It will be 0 if a and c1 are magnitudes are equal, but this is not mentioned here and you cannot prove also that two are equal. So obviously this is not equal to, this is not cancelling out, so these are not equal to 0. Okay. Next for this one, second one, I will a b1 is already 0. So a b1 is already, so obviously option D will not be the answer. It is a b2. Because a b1 I am already getting, b2 I have to check whether I will get. A b1 I am now check a c2. If any of these two are perpendicular, suppose a b1 and a c2, then you can say bc2 will also be perpendicular. Because in 3D, if these and these are perpendicular to this one, and these are perpendicular, suppose these and this perpendicular, these and this perpendicular, so obviously all three are orthogonal. You cannot have this and this perpendicular, then this in 2D it is not possible. If this and this A perpendicular to B and B perpendicular to C, you cannot have in 2D. For that you have to have 3D. So A perpendicular to B, B perpendicular to C. In 2D, why you will not have A perpendicular to B, A and then B perpendicular to C will make A and C parallel. They will not be orthogonal, but because in 3D you can do it. So if you try with AC2, you will see that AC2 is perpendicular. So A is perpendicular to B1, A is perpendicular to C2, and they are not coplanar. So they are not in same plane. So it is not possible to have in 2D. So obviously B1 will also. You have to be careful. If they are coplanar, then it can exist. I have shown you. A is perpendicular to B, B is perpendicular to C, then it is possible that A and C are not perpendicular, and it is possible if they are in same plane. But they have given it is non-coplanar. So obviously they are in 3D. So obviously then B1 and C2 will. So obviously all three will be perpendicular to each other. That's why it is option B. Now 16B again you need 3D, 16C also you need 3D, 16D, 17A, all these you need 3D concepts. What is asked here? A and B is given, C is given. A vector in the plane AB whose projection on C has a magnitude equal to this. So if you want to find a vector in AB, so you have to have a linear combination of A and B. So there are so many ways. You can write it in this way also, and then something lambda 1, then you dot it with C, it should be 0. You can find lambda 1, lambda 2, or you can take that I don't suppose that vector is alpha vector, so you've taken this alpha vector is this one, and this dot with C is equal to whose projection on C has a magnitude which is equal to 1 by root 3. So this dot I have taken as 1 by root 3. Actually this dot divided by C magnitude is 1 by root 3 because projection on C. So this dot C they have already given, divided by C magnitude is root 3, that should be 1 by root. So you find the equation, and because your lambda should be between A and B in the plane A and B, so you can try with this one also, box ABC, box AB and lambda should be 0 because they are at same plane. That's also you can do. There are lots of ways you can do, and also because lambda is in AB, so lambda can be a linear combination of AB, universal law of 2D. So it can be a lambda 1 into lambda 2. So you can find x is equal to this, y is equal to this, I, j, z equal to this. Now without solving this one, you can try with obviously you can try with option this one, which option is satisfying all these things, with which box should be also 0, and C dot magnitude, that projection should be also 1 by root 3. But from here only x and y, if you open it, you will see these two are always equal, x and z. So only one option you will find these two are equal, that is option A. Option B it is minus, option C it is. So from here only you can say it is obviously option A. Actually this should be I plus j minus k. So you will, if once you do it is minus k, then this one, and it has magnitude 1. So it actually mod is actually 1. It can be minus 1 also. But magnitude they are asking, that is 1. So if you see this one, your x and z equal, only option A is the same. And if you add this also, 4 minus 1 minus 4. If you add this one, x, then y, then z. So 4 get cancelled, it is minus 1. Actually magnitude, so that's why it is 1. So obviously it is option A. It's satisfying both this condition. You can obviously try from option which option satisfies the condition. That will also work. 17C again on 3D. 17D also 3D. 17E is also on 3D. The number of distinct real values of lambda for which these vectors are coplanar. Again for coplanar, what we will do, box is 0. So those who know determinant, you can do some Ziegler-Nielsen. You can do some column transformation, row transformation, so that it becomes a little easier to open it. Those who don't know, directly open it from here. You will find some expression, you will simplify it, you will get lambda, you will get 2 values. But it will be better if you do some simplification, make some zeros. 1 minus 1 will be 0 here, and you can take this common, and then it becomes very easy to expand. But you can directly expand, then also you will get 2 answers of lambda plus root 2 and minus 2. So answer is option C, that is 2. Now if you come to 18b, ABC are 3 unit vectors such that this is 0. Which of the following is 0? Now what is the meaning of this one? A plus B plus C is equal to 0. That means they all 3 are at same plane, because C is a linear combination of A and B. So if any vector is a linear combination, that means they are coplanars. So and you see this, if this is A, this is B, this is C, A plus B plus C is equal to 0, that means they are forming a triangle. Because I know this is A, this is B, then it becomes A plus B. And because your A plus B is equal to minus C, so that means they are closing the triangle. So triangle is closed. So in that triangle we have the very first question, that is question number 3, first or second, the third 3 1 suppose. Here we have seen the area of this triangle is half A cross B, half B cross A, half C cross A. That is, the magnitudes are also equal, and if you see the directions also all are, A cross B is in up, B cross C is up, C cross A is up. So all the directions are equal and their magnitudes also give me the area half of that magnitude. So all these three, they are, you can see obviously this is not equal to 0 because they are giving area. So A cross B, B cross C, C cross A is not equal to 0. That's why this is the option, correct option. A cross B, B cross C is not equal to A cross C because it should be equal to C. Then the order, because if it is A cross C, then your arrow is downward, but A cross B is upward. So these two will not be equal. If this order is equal, and they are not equal to 0 because it is area, and they are not obviously mutually perpendicular, because A cross B, B cross C all are coming up. That means all are parallel to each other. All of them are collinear in option D. They are not perpendicular. So B is the answer. Now if you come to 18C, the vectors this PQ, QR, RS, ST, TU, UP, they represents the sides of a regular hexagon. Then this is equal to 0, this option statement 1 and 2. So let us see. Because it is hexagon, so if you see the angle, this angle will be 60. All these angles 60, 60, 60. So each angle will be 60, 60, 60. So these angles are 120. So if you see RS plus ST, RS plus ST, because the first one is this cross is not equal to 0. So that you have to see, cross means two vectors cross will not be 0 if they are, when it is 0, two vector cross, when they are parallel, that is sin 0 is 0. So you have to see, they should not be parallel. So if you see RS plus ST from the diagram only, you can see these and these will not be parallel because PQ at 0 angle, so obviously this will not be at 0 angle. You can find these angles if you want to do. If it is 120, then it is 30, 30. So this angle is 30. You can draw this line, you can find these angles, everything, because this angle is 60. So obviously this angle is 30. From here it will be 120, 150. So obviously that is not required. You can see it is not perpendicular. So option A1 is correct. Come to option 2. PQ is not cross RS. PQ cross RS. Obviously again RS, this angle is 120. It is at 0. So this cross will not be 0 because there is some angle between them and they are not parallel. So obviously this is not equal to 0 because the angle is obviously not 0 or 180. So obviously statement 2 is wrong. So that's why option C. 1 is true, 2 is wrong. Statement 1 is true, 2 is wrong. If you like the video, then press the like button and please give your valuable comments in the comment section.